This lesson is on solving right triangles, and to solve a right triangle means that you're finding the lengths of all the sides and all the measures of all of the angles for that triangle. Now you will be given some information enough to find the missing pieces, so not everything will be missing. Here is our first example where we have some things given to us and some things are missing. The first thing I like to do is identify everything that's missing. First of all, I am missing angle B. I'm also missing side A and side B. And I like the angle one first because it is the easiest to find in this situation. You don't have to use trig to find it, because if you know that the angles of a triangle add up to 360, then you just have to do add up to 180. Do 180 minus 61.7 and 90, because those are the two angles that you already have. And so when you subtract there, you get 28.3. And so that is 28.3 degrees for angle B. And make sure you put the degree symbol on the angles. Your sides should not have symbols on them, unless you have some markings for measurements like meters or feet or something like that around the sides of your triangle. Okay, now to find side A, I'm going to look back at what they have given us and determine which of the trig functions that I can use to find side A. I know the angle down here at 61.7, and yes, I did find angle B, and I could use that if I wanted to, but I like to kind of stick to what they've given me. I know the hypotenuse, so that's pretty useful, and then A that I'm trying to find is according to the 61.7, or from the perspective of the 61.7, it is the opposite side. So if I'm looking that as my opposite side and my hypotenuse is 106.2, opposite and hypotenuse go with sine. So I'm going to say sine of 61.7 is A over 106.2. And then to solve this equation, I'm going to have to get rid of this fraction. So I'm going to multiply by the denominator of 106.2 on both sides. And it should cancel out over here, and I should just be left with my A. And then I just need to type in 106.2 times the sine of 61 degrees, which ends up to be 93.5. And so I'm going to list that 93.5 over here. And this is a link, so I don't need to put a degree mark with it. And I can tell that the last thing I need to find is side B. And from the perspective of the 61.7 degree angle, it is the adjacent side. So B is our adjacent side. Again, my hypotenuse I know for sure is 106.2. Adjacent and hypotenuse go with cosine. So I'm going to say cosine of 61.7 is adjacent over hypotenuse. And again, I have a situation where I need to get rid of a fraction, so I'm going to multiply by the denominator. And these are going to cancel out and leave me with B. And I just have to plug this left-hand side into my calculator and get 50.3. So 50.3 for side B. And that completes everything I needed to find out about that triangle to solve triangle ABC. Alright, we're going to move to another example. We are trying to solve triangle DEF, and this has some different things missing. I am missing a couple of angles here and a side. So I'm going to list those. I'm missing angle D, angle F, and side D. And where in the last problem the angle was easy to find, this time it's not so easy because I'm missing two angles instead of just one. So I don't exactly know how to subtract if I don't know everything that's there except for just one angle. So although the angles are harder to find, the side is not. I actually don't even have to use trig to figure out D because it is a right triangle, and anytime I'm looking at the sides of a right triangle, they are related by the Pythagorean theorem. So I can use D squared plus 13 squared equals 23 squared. And so 13 squared is 169. 23 squared is 529, If I subtract 169 from both sides, I'm going to get 360. And then if I square root both sides, the square root of 360 can be broken down into 36 and 10, so that would be 6 square roots of 10. And I could get the decimal there because they didn't tell me what form they would like to be in, but I'm going to use the exact answer, which is 6 square roots of 10. Now to get one of my angles, I'm going to start with D. I'm just going to look at two of the sides that I know for sure. I know the 13 and the 23. In relationship to the D, the 13 is the adjacent side and the 23 is the hypotenuse. So adjacent and hypotenuse go with cosine. So I'm going to write the equation cosine of D is 13 over 23. Now anytime that the angle is what's missing, it's not as easy to solve. You actually have to use the inverse, and so your D will be the inverse cosine, and that button again is you have to do second cosine on your calculator. It should be written in blue above your cosine button. So cosine inverse of 13 divide 23 in your calculator, and make sure you're in degree mode before you do that. You should get 55.6, and that will be degrees because D is an angle. So 55.6, make sure you put a degree mark. Then finally, for F, we are going to be looking at 13 as being the opposite side because you can draw across from F to get the 13. And then 23 is still the hypotenuse. So opposite and hypotenuse go with sine, and so I'm going to solve this saying sine of F is 13 over 23. Again, I'm missing the angle, so I have to do an inverse. This time it will be the inverse of sine, so sine inverse 13 divide 23 in my calculator, and that should give me 34.4 degrees. So 34.4 degrees. And these are all the missing pieces, so that should complete my answer. I have answered everything they asked. Okay, now we're going to move to some applications. Applications is just a nice fancy word here for word problems. And first we're going to talk about two vocabulary words that you need to know, or vocabulary phrases more likely. The angle between the horizontal and a line of sight above the horizontal is called an angle of elevation. So angle of elevation. Now I'm going to kind of draw out what they were talking about. The horizontal, so horizontal is flat, and line of sight above. So in other words, you're looking up. This would be an angle of elevation. The second sentence, the angle between the horizontal and a line of sight below, so below being the key word there, the horizontal is called an angle of depression. And so again, you have a horizontal, which will be flat, but a line of sight below means you're looking down at something. So what I would like for you to keep in mind is that an angle of elevation should be flat or horizontal on the bottom, and an angle of depression should be flat or horizontal on the top. And that's going to keep your drawings labeled the right way. And we're going to do some examples, so I'll help you label those. Okay, for example 3, we are going to estimate the height of the tree. There's a man that walks 27 feet from the base of the tree, and he estimates the angle of elevation to the top of the tree to be 70 degrees. Approximately how tall is the tree? So we have a tree here and the ground, and we're going to assume that I have drawn perfect lines because it would be, but we'll just do our triangle from that. And the guy has walked 27 feet from the tree, and he's looking up because it says angle of elevation, and he's estimating that to be 70 degrees. Now obviously I am not drawn to scale here. What we are trying to find is how tall the tree is. So I'm going to put the X on the tree because that's what I don't know. And then we're going to assume that the tree makes a 90-degree angle with the ground. Now these problems, once you get them drawn, should be easier than what we did in example 1 and 2 because you only have to find one thing. In those two examples we were finding 3 things each, and so now we're just going to focus on the one missing thing. I have the 70-degree angle identified. If I look, x is opposite and 27 is adjacent. Opposite and adjacent go with tangent, so my problem becomes tangent of 70 degrees is x over 27. Then I'm going to multiply on both sides by 27, and I'm going to type that in my calculator, and I'm going to get 74.18 feet. I'm putting feet on it because there were units in this problem, but it's just as simple as working one of these out. I will say that we're probably going to run into a lot of tangent situations because if you think about if you're able to measure things in the real world, you can measure on the ground easily, and then there are tools that can help us use the measure angles, and sometimes things are very, very tall. We may or may not know those, but the tangent situation happens a lot of times in real situations. Okay, example 4 is a similar situation to example 3, and if you feel confident about what we did in example 3, example 4 is a good place to pause and try this on your own. And so if you want to do that, you can. If not, you can just stay with me and I'll explain it, but if you do want to, you can pause now. Okay, for those of you who have stayed with me, or if you did pause and try it yourself, we have a flagpole casting a 42-foot shadow. So here's my flagpole, here's my shadow. Shadow is 42 foot. The angle of elevation of the sun, so the sun would be over here and you're looking up toward that, and that would be 57.4 degrees for that angle here. What is the height of the flagpole? And again, my x is here. So it's really similar picture to the last one. I have the opposite side and the adjacent side identified again. So that would go with tangent. So tangent of 57.4 would be x over 42. Again, I'm going to multiply by denominator. And just type the 42 tangent 57.4 into my calculator and get 65.7 feet. Alright, for my 5th example, we're going to do something a little bit different. We'll still just be missing one thing, but we'll be missing something different this time. So we have a 37-foot tree. So here's our tree. We know it's 37 feet this time. It's going to cast a 27-foot shadow, and obviously I am not drawn to scale. The question this time is, what is the angle of elevation? So I'm going to call that theta, or you can call it x, whatever variable that you'd like to choose. But the two sides I have labeled in relationship to that are the opposite and the adjacent. So again, I'm using a tangent. This time tangent of theta is going to be 37 over 27. And this is a situation like we had in example 2 where we were missing an angle. And anytime you're missing an angle, you're going to have to do the inverse. So this time it's a tangent inverse. So tangent inverse of 37 over 27, or 37 divided 27. And you'll type that in and get 53.88 degrees. Make sure you put a degree mark on it because it is an angle. Okay, our last example is going to deal with an angle of depression. We haven't had one of those yet. So we have an airplane that is flying 4,000 feet above the ground. So we're going to say that this is my airplane. It is 4,000 feet above the ground. And this is my ground. It says if the angle of depression from the airplane to the beginning of the runway is 5.4 degrees, so a very small amount, what is the horizontal distance to the nearest tenth of a mile of the airplane to the beginning of the runway? Okay, so I'm going to have a runway. I'm going to say that the runway starts over here, and this is the runway at the airport. And I'm going to read that sentence again. If the angle of depression from the airplane to the beginning of the runway. So the airplane to the beginning of the runway is here. The angle of depression has to be flat on top. So we're talking about this angle here being 5.4 degrees. And the question is, what is the horizontal distance? Horizontal, again, flat, would be this distance here between the plane and the runway, but it's the horizontal part only. So, if you're looking at this and thinking, I have a couple things on this triangle, but this is not inside the triangle, it's outside the triangle. I do know that this is 90 degrees. What can help is the fact that this line up here on the top of the angle of depression and the ground are theoretically horizontal, and I just, can't exactly draw that here. I have some wavy lines, but those are supposed to be horizontal, which would mean that they're parallel. And being parallel, I have a theorem that says alternate interior angles are congruent. This 5.4 is alternate interior angles with this angle down here, so it is also 5.4 degrees. So that is an alternate interior angle situation. Another option would be to find the complement to 5.4. The top angle right here would be whatever 90 minus 5.4 is, and I point that out because you can use that. Some people jump to the conclusion when they're doing a problem like this that this angle in here is 5.4. Because they forget that an angle of depression has to be flat on top. But it's not. It's actually the complement to the 5.4. And you can label that and use that instead. I just happen to tend to use the alternate interior angles, so I wanted to show you that for my future examples as well. Okay, so let's get to solving. Now that I have things inside of the triangle, I'm not going to worry about this outside 5.4, but I am going to look at my sides in relationship to this inside 5.4. I have the opposite side and the adjacent side, so yet again I am using tangent. So tangent of 5.4 is 4,000 over x. And I'm going to have to get rid of the fraction, so I'm going to multiply both sides by x. So these x's are going to go away. And now when I have x tangent 5.4 equals 4,000, I need to get the x by itself. It's being multiplied by tangent of 5.4, so I'm going to divide by that to get rid of it. So x is going to equal 4,000 divided by the tangent of 5.4. And when I type that into my calculator, I'm going to get a pretty big number, 42,315.57 feet. Okay, so that's pretty good. We've got the answer. The only problem is they asked for this in tenth of a mile, and this is actually in feet. And the way I know it was in feet is because the 4,000 was in feet, and that's the number that I used to get that. So I need to convert. There are 5,280 feet in 1 mile. So I'm going to divide this large number by 5,280 to determine how many miles I have. So when I do that, I get 8.0 miles. And that correctly answers the question. Although this was a correct answer, they did not ask for it in feet, they asked for it in miles. So you want to make sure if they do something like that, you are paying attention. So that concludes this lesson.